If you're watching this on video, push pause, print out the truth table connective review sheet and quickly fill that out. Otherwise, for all of us that are live, we are getting started. So just real quick, reviewing the truth table facts, you're going to help me out here. So the first one, the negation. What does the negation do to the truth value of your statement? It makes the true one false and then makes the false one perfect. It just reverses the values. Great. We're 1 for 1. Great. The next one's the conjunction, your and statement. Sometimes the word but is used. When is the conjunction? When is the and statement true? That's the only time when they're both true. So the first row, true and true is true. The other times I've got false, false, false. Everybody with me? Any questions? If you have a question, ask it. This is the most important thing for you is to remember these truth table facts because they're essential to everything. The disjunction, the or statement. When is the or statement true? When either one is true, right? So true or true, that's going to be true. True or false, that's true. False or true, that's true. And then lastly, false or false is false. Great job. All right, then the last two. This was section 3.3. The conditional statement. The conditional statement, I think, is the trickiest one of all of them. What is the only time the conditional statement is not true? True then false. When you met the condition, but you did not get the consequence promised by the conditional statement. The example I used in class was if you get above 90 on a test, then you should get an A. So what true then false means is you got a 95 on the test, so you got above a 90, but you did not get an A. Okay, that is the false example. Okay, all the other ones are true. This one's true because you met the condition, you got the appropriate consequence, all is good. These ones are a true conditional statement because you did not meet the condition. And since you did not meet the condition, logically, this conditional statement does not apply. So that's like if you got an 82 on the test. If you got an 82 on the test, then the statement, if you get above 90, then you get an A, does not apply. Okay, for that reason, logically, that's why these are true. Okay, and I know that that's sometimes the goofy thing to wrap our brain around. The biconditional. When is the biconditional statement true? When they have the same value. Yes, the biconditional is a conditional statement in both directions. So the reason that this one's false is because this is true then false, and we just saw in the conditional that that was false. And then this one, false then true, that would be fine. But then when I turn around and I read this from right to left, I have true then false. And we just saw that that is the bad one in the conditional. And so then that's why these two are true. So there's your 5 basic truth table facts. That's the big deal to remember. Like I said, I've put another one on the back. So when you're feeling it today or tomorrow, review real quick again, grab some extra ones. This is also linked on Canvas for you. You can print out as many copies. I have a video that I made a couple semesters ago of just me going through the 5 basic truth table facts in case you forget anything. Okay, that's also linked on Canvas. Okay, so it's all there for you so that you can get exactly what you need. In the meantime, now we're going to go back to section 3.4. We're talking about what makes statements equivalent. So again, just to refresh your memory, 2 statements are equivalent, which in logic is symbolized with an equal sign with arrows on the end. They're equivalent when they have the exact same truth table. And we did an example of that. And if you were not here last time, that's all of this is on video. You'll see these beautiful colors. And then we talked about the first of 3 specific equivalences that you can take to the bank. The first one was called DeMorgan's laws. And DeMorgan's laws functions like a distributive property for our parentheses and the negation. And you can see it right up there, but just trying to review, because I know we have a test in a week. What is the one thing you have to remember? It's not exactly like arithmetic. When I distribute the negation, what other thing do I have to do? I have to flip either the conjunction or disjunction sign. This only applies for the conjunction and disjunction. Okay, this does not apply for a conditional or a biconditional statement. You can't just distribute the negation in those situations. Okay, but then if you have a conjunction when you distribute, it becomes a disjunction. When you have a disjunction, you distribute, it becomes a conjunction. We proved that. Okay, proving is a fun word to say, but you actually did it. And then where we ended off is we just used DeMorgan's laws to write an equivalent statement in words. Okay, so we did that, and that took us now to the second equivalence. So once again, I know I've just zoomed through that. If you were not here, that's all on video, so you can find that in Canvas, and you can watch and just not get enough Perkster. Okay, so here's the second equivalence. The second equivalence that we can take to the bank involves our conditional statement. There is a statement that is equivalent. There's another conditional statement that is exactly equivalent to the conditional statement. So we're going to go through 4 different things, and sometimes we get some of these confused and think they're going to be equivalent when they're not. So here we go. I tried to think up the shortest things I could so that we don't have a whole lot of writing. So I am defining statement P as it rains, statement Q as I get wet. Okay, just 2 very short statements. And so what we're going to do is we're going to write our conditional statement in words, and then we're going to see the 3 other conditional statements that are related. One's called the converse, one's called the inverse, one's called the contrapositive. So I'll do the first one. The conditional statement just says P arrow Q. So what is this going to be in words? How am I going to start this statement? If, okay, if P, which exactly right is it rains, then what? Perfect. Love it. Thank you so much for your help. Then I get wet. Pausing for a moment just so that you can catch up. I don't want to get ahead on this and have you scurrying to write things down. Okay, so the next conditional statement that is related to it is called the converse. Now notice what's happening in the converse. The converse, I am taking the original conditional statement, and what I've done is I've flipped the order of the 2. So now instead of P then Q, it is Q then P. So converse means flip the order. So real quick, just write down what the converse is in words. Give you 30 seconds to do that. Okay, so this time we start off if, and it's if what? Perfect. If I get wet, then what? It rains. Perfect. You're doing great. Okay, so the prefix con has to do with the order. So the converse just means I have flipped the order around. The next one is the inverse. Now notice what's happened with the inverse. Instead of P then Q, I've kept the same order, so I have not flipped the order, but what I have changed is the negation. I've negated both of them. Okay, so please real quick write down in words what the inverse is. So this one I start out if, and if what? Okay, so if squiggly P, so P is it rains, so squiggly P if it doesn't rain, or however you said that. Then what? I don't get wet. Great job. Last one. The last one's called the contrapositive. And notice the contrapositive has done both of these things. The prefix con, again, deals with the order. Okay, so the order has been changed in the 2 statements in addition to the negation has been done on 2 statements. So it gets both. So go ahead, please, and write down what that is in words. So this one starts off if what? Perfect. If I don't get wet, then it did not rain or it doesn't rain. I'm not really concerned about which tense it is. You're just giving me the negation, okay? Then it didn't rain or doesn't rain or whatever. Everybody tracking with me on this? Okay, again, we spent a long time in section 3.1. It was a really boring class, I understand. And we just converted between symbolic and written statements. And the reason we spent the whole time was hopefully so things like this are nice and straightforward for you at this point. So here's what I would like you to do now. My original conditional statement means the exact same thing as one of these three. So what I would like you to do is do the truth table and determine which one is the conditional statement exactly equivalent to, which is great. So if you're in your English class writing an essay and you write an if-then statement, then I'm going to give you a way to double your words for free. Okay, you can just then do one of these others. So go ahead, I'll give you about 2 or 3 minutes to make as much progress as you can. All right, I'm going to get started. If you're still working, keep working. Okay, I know we all work at different paces. So first thing I'm going to do is I'm going to do a column for if P then Q. This is my straightforward conditional statement. We already reviewed that at the beginning of this class in this video. So the conditional statement is true at all times except for T then F. So here we go. We've got T then T, that's true. T then F, that's false. F then T, that's true. And F then F, that's true. Next, I'm going to do the converse. The converse is what I get when I flipped the order of the two statements around. So instead of P then Q, let me do this other thing because I asked what one is it equivalent to, what one's equivalent to the converse. So I'm going to put a little asterisk under there because I'm looking for a column now that goes TFTT. So I'm going to do the converse now, which I'm going to flip the order, Q then P. So now I'm going backwards. Again, my conditional statement is true at all times except for T then F. Now I'm going from right to left. So Q then P. So T then T, that's good. The next one, F then T, that's good. The next one, T then F, that's bad. And then F then F, that's good. So we notice that's not the exact same thing. Okay, so that is not logically equivalent. Now, sometimes we think it is. Okay, when we're just using language ordinarily, we think we can flip the order of the condition and the consequence, but it means something different. Okay, it's not logically equivalent. Okay, so the next thing that I'm going to do for the inverse and the contrapositive, both of those, I need the squigglies. If you already did this earlier, that's fine. So I'm going to do a column for squiggly P, and I'm going to do a column for squiggly Q. Again, you already reviewed this with me. The negations just change the value. So P is TTFF, so squiggly P is FFTT. And Q is TFTF, so squiggly Q is FTFT. So now the inverse is what I get when I leave the order of the original statement, but now I negate, so squiggly P, then squiggly Q. So here we go, my conditional statement is true at all times except for T then F. So here we go, F then F, that's fine. F then T, fine. T then F, that's the false one. T then T, that's fine. This column, notice, is not the same exact thing as my purple column. So nope. One more, last one. So the last column or last one is I'm going to do the contrapositive. The contrapositive is what you get when you negate and you flip. You do it all. So I'm going to go right to left with my squiggly Q and my squiggly P. So here we go. I've got F then F. That's good. T then F. That's the bad one. Excuse me. F then T. That's good. And then T then T. That's good. And you notice I've got the exact same thing that I started with, TFTT. So which statement is equivalent to the conditional statement? The answer to that is the contrapositive. So when you have a conditional statement and you flip the order and you flip the negation, you have created an equivalent statement. It means the exact same thing. Now you may have noticed, hey, Perkster, the converse and inverse, they have the same column, and you're exactly right. They are contrapositives of each other. Okay, so the converse and inverse are contrapositives because you flipped the order and you flipped the negation. Okay, so what you need to remember out of this, long and short of it, is when you start with a conditional statement, it's the contrapositive that's equivalent. So what I would like you to do, please, top of the next page and our last page for this section. Exercise 7 has you do something similar to what we did when we went over DeMorgan's law. I've given you a statement in words. I want you to write the equivalent contrapositive statement. If you need to define variables and write it symbolically, that is great. If you can do it without doing that, that's great too. Okay, just do what you need. Okay, so I'm going to get started on this. Again, if you're still working, I'm not trying to rush you or shame you. I'm just trying to make sure that I'm splitting the difference between people done and not done. So we all work at our own pace. So first thing I'm going to do, if you needed to do this, great. If you didn't need to do this, that's fine too, does not matter. I'm going to define my simple statements. So the problem says if the quadrilateral is a parallelogram, then the opposite sides are parallel. So statement P is the quadrilateral is a parallelogram. I'm going to abbreviate. The quadrilateral is a parallelogram. Then the opposite sides are parallel, so Q is the opposite sides are parallel. Okay, so then what that means is my statement right here, since it's an if-then statement, it starts with the word if. I'm going to use my arrow. Okay, if the quadrilateral is a parallelogram, that's P. Then the opposite sides are parallel, that's Q. I asked you to write the contrapositive. The contrapositive is what you get when you flip the order and the negation. So I've got squiggly Q, then squiggly P. Okay, that's the contrapositive right there. Again, all of that is just preparation for what I wanted. And once more, I'll say, if you did not need to do that preparation, if you're super confident that you know what the contrapositive is, then that is swell. Okay, so now what I'm going to do is if the opposite sides are not parallel, then the quadrilateral is not a parallelogram. Yeah. You only have to write the symbols if I ask for it. Okay, so on the test, because I will want to be testing things, some of the problems I will ask you to write in symbols, but if the problem was given just like this, the instructions just say rewrite the conditional statement as the equivalent contrapositive. If that's the question, then you do not have to define the simple statements and write it in symbols. This is just if you need to. Okay, so either way. So as far as equivalences, you can always show two things are equivalent by using the truth table. But there are some equivalences we could take to the bank. The first was DeMorgan's law. The next one was the conditional is equivalent to the contrapositive. There's one more equivalence that involves the conditional that we're going to talk about. It's the conditional equivalence with a disjunction. So if I have a conditional statement, P then Q, then it is equivalent to, and I'm going to write my arrow with the equal signs on both sides. It is equal to the following, disjunction. What you're going to do is you're going to take your condition and you're going to negate it. So squiggly P. So I took my condition, whatever it is, I'm going to negate it. Or, because it's a disjunction that we're equivalent to, then you leave the consequence alone. You don't do anything to the consequence. So I'm going to put a Q right there. So if you start out with a conditional statement, then when you form the disjunction in this way, then you get an equivalent statement. So for instance, just as an example of what this sounds like, I'm just going to take the sentence from exercise 7, and we're going to write it as a disjunction. That means the same thing. So if the quadrilateral is a parallelogram, then the opposite sides are parallel. So what I'm going to do is I'm going to negate the condition. So the quadrilateral is not a parallelogram, or you leave the consequence the same. And the consequence was the opposite sides are parallel. Logically, that statement I just wrote means the exact same thing as the conditional statement in exercise 7. Okay, they are the same. So here's our last exercise for this section. It's just practicing some of these equivalences that we can take to the bank. So here's what we're going to do in exercise 8. I have defined two simple statements for us. Okay, statement P is X is greater than 0. Statement Q is X is negative. Here's what I would like you to do first. I'm going to give you 30 seconds. Take this given statement right here. It is not true that X is greater than 0 and X is negative. Write that symbolically, please. This statement starts off with "it is not true." So this is another opportunity for us to do a little reviewing. When a statement starts with "it is not true," what do you do symbolically? You put a squiggly and some parentheses. That's exactly right. It is not true or it is false. That's what it starts with. So it is not true that x is greater than 0. So that is P, and conjunction, and x is negative. So Q. So what we're going to do is we're going to show, or we're going to determine, which of the three statements below that given statement is the same thing as, is equivalent to. So as a first step, what I would like you to do for numbers 1, 2, and 3, write each of those statements symbolically. 1, 2, and 3, write each of those symbolically. Okay, so statement 1 starts with the word if. So I've got a conditional statement, so I'm going to put an arrow. So if x is not negative, okay, so statement Q is x is negative. So since there's a not in there, that's squiggly Q. Then x is not greater than 0. So statement P is x is greater than 0. So that is squiggly P. Anybody got a question about that? You doing okay? All right. The next statement, number 2, is x is not greater than 0. So again, I've got a not, so that is squiggly P. Or x is not negative. So or squiggly Q. And then last but not least, statement 3 is x is not negative. So that's squiggly Q. And x is not greater than 0. That's squiggly P. So here's what I would like you to do next. If I want to, so if you're on the test, just as an aside, if you're on the test, I'm going to ask you to do something like this. I'm going to give you a couple statements, 2 or 3 statements, say, determine if these are equivalent or not. And you're welcome to use these equivalences we now have. But if you forget, if you blank on them, then remember, you can always do a truth table. Okay, so you could do a truth table that included all 4 of these statements and then determine which columns are the same. That is a totally legitimate and fine thing to do. But we're going to practice the equivalences. So here's what I would like you to do. Not all of these statements have parentheses or an if-then. So what I would like you to do is use the 2 equivalences we know. You're going to use DeMorgan's law for my original statement to write an equivalent statement. And then you're going to use the disjunction equivalence that we just talked about to write an equivalent statement for 1. That way we can then compare which ones are the same. So give you a minute or 2 to write those equivalences down. Okay, the top statement, when I use DeMorgan's law to distribute the negation, I have squiggly P. And then DeMorgan's law says I'm going to take this conjunction and it's going to be what? An or. Perfect. And then I have squiggly Q. Okay, so that is the same thing. Now we'll be able to look through and compare. The next statement, statement 1, I'm going to use the conditional disjunction equivalence that we just talked about. So let's real quick review that. What that says is you're going to take the condition and you're going to negate it, or you leave the consequence alone. So I'm going to take my condition and I'm going to negate it. So when I negate squiggly Q, what does this become? What do two negatives make? A positive. So when I negate squiggly Q, it becomes positive Q. Or, and then I leave the consequence alone. I don't do anything to that, so it's going to stay squiggly P. All right, now all of these statements are of a similar format. So now we can compare which one or which ones, there might be more than one, which one is the same as squiggly P or squiggly Q. Well, first, is statement 1 the same thing? Why is statement 1 not the same thing? I'm sorry, I didn't hear what you said. Perfect. The Q is not negative. It's missing a squiggly in front of the Q. Okay, so statement 1 is not the same as the original given statement. Everybody seeing that? How about statement 2? Is statement 2 the same as the original given statement? Yes, it is. I've got squiggly P or squiggly Q. So that's good, but let's just confirm, make sure there's not more than one answer here. How about statement 3? Is statement 3 the same as the original statement? Why is it different? It's an and, it's a conjunction. Perfect. That's why that one's different. So I cross that out. So which one is equivalent to the original statement? That would be statement 2.